This is a demonstration of Gay-Lussac's law for National 5 Physics. So what we've got here, our hot plate stirrer, got a glass beaker, got a magnetic stirrer, got a pressure gauge attached to a long tube and then a glass bulb at the end, and we've got a thermometer. The important thing to note about this system is that it is completely sealed. There's no air getting in or out, so it is a fixed volume and fixed mass of air, because this glass, you can't expand it, it would just shatter. So what I'm going to do here first is fill up the beaker with cold water. So I've filled my beaker up with cold water, turned on the magnetic stirrer to keep the water circulating, and replaced my thermometer with a digital one, which hopefully shows up better. So I've zoomed into the pressure gauge and thermometer. As you can see, we're currently reading 13.1 degrees Celsius and 0.88 on this scale, which is in times 10 to the 5 pascals, or 100 kilopascals. So we're currently reading 88 kilopascals. 100 kilopascals here at the top of the gauge is around normal atmospheric pressure. I will turn the heat up on my stirrer hot plate and I'll get back to you when we reach a new temperature. So we're at 20 degrees Celsius and we're probably at 89 kilopascals. So we're at 25 degrees Celsius and we've just passed 90 kilopascals. We've just passed 30 degrees Celsius and we're at 91 kilopascals. We're at 35 degrees Celsius, 92 kilopascals. Hopefully you're beginning to see a trend here. We're at 40 degrees Celsius, 94 kilopascals. 45 degrees and 95 kilopascals. We are at 50 degrees Celsius and at 96 kilopascals. And that's probably enough data points for this one. So what we have in this experiment is as the water heats up and heats up the glass bulb, the air inside is given more energy. That means the particles start to move faster, but they can't expand this glass tube or the glass bulb without breaking it. So what happens is the pressure increases instead. I'll put the results I've got from this experiment in a table and include it at the end of this video. You may also want to think of ways to improve this experiment. Perhaps things aren't as accurate as they could be.